Sewade now to start his presentation on Matplotlib. Thank you.
Yeah. Hello, everyone. I believe you can hear me, right?
Yes, we can hear you, Sewade. And can you
Okay.
zoom in a little bit for us?
Should I do what?
Can you please zoom in a little bit for
Okay.
us?
Okay. Can you? Is it okay
Yeah,
like this?
yeah,
Okay.
it's fine. Thank you.
All right. Yeah. Great. Okay. Great. Just 1 second, please. Okay. So, hello, everyone. I believe you've learned a lot over the 2 days, and you've been seeing different things you can do with Python, and I know you've been doing more of computations, but this final course will be more of the visual aspect of Python, in which you want to plot your data and do some other things with your data. We've been manipulating data, but right now we want to plot, and that's really interesting for us. I know. I hope you will enjoy this part. So now, let's first talk about data visualization. Most times, imagine you are working for a business and you need to present something to the business. Most times, after getting your data, you discover that you don't want to present the data to the business or to your boss. Most times, you want to create charts and plots in such a way that it is visually appealing to your business or to your company. And so that's why data visualization is important. You can use the other tools you've learned to manipulate your data, but when it comes to presentations, most times you want to make plots. So there's a Matplotlib package that is based on Python that we'll be using, and I believe you will enjoy it. It has a lot of settings you can do, but you just have to be ready to actually play with it. That's all. So the kind of so Ben, so that's it. So we are going to be visualizing different things. We'll be trying out different things, but I would try to take it one step at a time, all right? So that we can really understand what we are trying to do there. Now you discover that there are many types of plots. We can make. I know from your tertiary or primary education, you'd have heard of pie charts, bar charts, histograms, scatter plots. There are a lot of plots you can make, and everything depends on your data. So your data will provide the kind of plot that is very feasible for your business. So that's the thing. So you don't just look at data and just say you want to use any form of plot. You have to really consider which plot is suitable for your form of data. So because of that, even though I would like to go down into it, I would just want to show you some visuals about the different types of plots we can have, so that at least that will introduce you to. So I'll be able to introduce what we have here, right? So I'll stop sharing this and and um, and quickly, please, I'm coming. Yeah. Yeah. So I hope you can see this. Yeah, you can see my screen, right? Someone should just say yes if you can see my screen there.
Yes, we
Okay,
can.
good. Okay, good. So right now, I just want to show you some. Imagine you have your data points, and I give you an array, maybe array one, array one. I give you a list like this. Maybe 1, 2, 3, 4, 5, like that, like that, like that. I give you another array two, maybe 6, 7, 8, 9, like that, like that, like that. Now, even though this is data, but how do you really explain what this data means to us? Sometimes you might want to do different things with the data. So that's where different kinds of plots come in. For example, you can take one of the data and plot one on the x-axis and plot the other one on the y-axis, right? In such a way that array 1 will be on the x-axis, array 2 will be on the y-axis. And so with that, you can make maybe a straight line plot. You can make what we call scatter plots in such a way that you have different data points at different points. You can even create what we call a bar chart. You can create what we call a bar chart, like, let me show you. I'm just using this to refresh your, so you know what you should expect, a bar chart. You can create histograms with your data and things like that. You can create pie charts. So those are kind of plots you would expect to be able to create, with your data, even though you are just giving array 1 and array 2. But now, knowing which of the plots to use is a skill. All right, I want you to take note of that because we'll be doing a lot of plots and you'll wonder which one am I to use at the end of the day. So knowing different kinds of plots, that's why it's better you just know all the types of plots so that when you are faced with the kind of data, you will know what kind of plot to use. Okay. So I think that's just an overview that I wanted to give. And so now I'll stop sharing and come back to the code. So I believe when we start the code, you really understand what we are trying to do. All right. Okay. All right. So we are back now. So I've just briefly explained the kind of charts you should expect from Python. All right. So the first thing is we'll need some basic imports. You would have seen that other course instructors have been importing different things, and this is not also this is also going to happen here. We'll be importing our Matplotlib package. Now there's a sub module called PyPlot in which we are going to use for most of our plotting. So note that we've renamed it as PLT. PLT is just an alias for this. Most times we like to use alias so that we won't need to type this or we won't need to remember the long name, all right? So that's why you discover that NumPy is also renamed to NP. It's very easy for you to type NP than for you to type NumPy, all right? So that's why we do that. So the next thing is I'll just briefly generate some simple data that will help us to make our plot. So that's where the next place come in. You might want to ignore this seed, but what this basically does is that it's for reproducibility. So that when anybody wants to reproduce my chart, the person can always reproduce the chart. That's why I set a seed. So this seed is like a number in such a way that when I give my plot that number, every time I plot, I always get the same thing, especially when you are using random numbers, because here you discover that I'll be using random numbers to generate, my data. And so that's why that is there, right? So just to generate my data, I want to generate 30 data points. So that's why you see n equals 30 there. And the kind of data points I want to generate, the first one is actually a triangular, it will be in form of a triangle in such a way that it will have a mode, and the mode will be at the center. Let me see if I can just briefly highlight what I mean by that. It will be something like this, right? My data points will go like this and we come back like this. So imagine this is your x-axis and this is your y-axis. All right, so I'll generate data points like this, but most of the data points will be centralized around here. So that's why it's triangular, right? So that's what I mean by being triangular. So I'm just trying to show you. So someone also asked earlier that can we generate different distributions using Python. So this also shows that you can also generate different form of distributions. All right. So now the next one, you discover that for my X, I want to use a triangular form of data. For my Y, I'm generating random numbers that is normally distributed. So that's what this means. A Gauss is like a Gaussian distribution. And 0.5 is just the mean of the Gaussian distribution. 0.25 is the standard deviation. If you don't really understand what I'm saying, it's more of a mathematical thing. It's more of mathematics than what we're actually trying to do. But I just want to, for those that are into maybe science that understand what probability distributions are, they might be interested in something like this. So that's why this is interesting. And you discover that automatically inside the list, I can even run functions inside list. You can see that Python is really interesting. We call this list comprehension. I know you might not have seen this before, but it's possible for you to run something inside of a list and automatically generate it. So that's what this does for you, you know. So I'm also generating colors and areas, but you can just ignore this. This I'll try to come back to later. So let's view our X and Y axis, you know. Sorry, our X and Y data points. So that's what I try to do here, printing them. So these are the data points that have been generated for me, you know. And so you might also want to ask that, why are we generating data? Most times when you are performing experiments and when you are trying to, or maybe when you have an hypothesis or you have an idea, what you want to do first is you want to to first test that idea on data points, generated data points, or what you call is this don't let me call them pseudo data, but what we call just data. Most times hypothetical data, exactly. Let me just call it hypothetical data. So that's what you use this kind of stuff to do. You know, imagine to type all this myself. It will be so long that you might not be able to finish. But by generating data, I can quickly iterate and just check if I have a proof of concept. So that's what this helps to do. So remember that we've generated X and Y data points. As I showed you, we need X axis and Y axis. So let's go into how we actually do the plotting, all right? I believe that point is clear, right? If you have questions, you can always leave them in the list. I believe people are there to exactly knowing what to use is a skill. Please just have that at the back of your mind, you know. Yes, to get other probability distributions, you can always go into the Python documentation. Maybe if someone can help me leave the Python documentation and this in there for random, you know. If you go to random, you can see where you can generate different probability distributions from. You know, a lot of them are there. So I just showed two here, all right? But you can have a lot of them in the Python documentation itself. Okay, the range n. Okay, range n is range is. I believe someone. I think they will explain the range in the earlier session. But let me show you what range does. Range is like, now when I do for I in range n, it means that I want to loop over 30. N is 30 here. So I want to loop over 30 numbers. And for the 30 numbers, I want to generate random numbers. Are you getting me? Triangular random numbers. So that's what this means. So let me show you this list comprehension. I wrote, okay, you didn't see 30. Okay, good. So that's what the 30 is for. It has been declared up there. Okay, so let's go on into our scatter plot, the first kind of plot we talked about. So when you want to plot, the first thing is that you tell us first that you want to initialize a figure. That's what this plt.figure is here for. You have to tell us, oh, I want to create a plot. If you don't tell us you want to create a plot, we will not know that you actually want to create a plot. And so when you want to start plotting, you do this first, plt.figure. Don't forget that. Inside your figure, the beauty of the figure is you can then create a lot of things inside the figure. You can tell us the size of your plot. You can tell us the color of your plot. You can tell us different things inside this figure. And that's why when you see me highlighting on figure, you see what it brings out. It brings out a lot of things, right? Telling you figure size, DPI, face color, a lot of things are there. But we will not want to bug you with that for now. We just want to create plots, all right? So now, to create a scatter plot with data, what you just do is you just tell it plt.scatter and you give it your data points, your x-axis and y-axis. This is enough to actually create a plot as you are looking at it. Can you see? This is enough. So just tell us you want to create a plot, then you tell us what type of plot you want to create. That is a scatter plot. And it generates the scatter plot of the data points, the x-axis and the y-axis. So that's what that is there for. All right. So, but now imagine you create this kind of plot. Most times you want to do presentations. At least you want to tell us what the x-axis is, what the y-axis is, what different things are for. So that's why you also need to give us other declarations. You need to declare that, okay, I want this to be called this. I want my title to be this. I want, you understand? So that's why you discover that when we make plots, we don't just initialize and just stop there. We need to bring in other variables, all right? That's why you see this one, this axis is actually telling you that the x-axis should span from 0 to 1.0. That's why you see that x-axis is from 0 to 1.0. All right. Now you discover that without specifying this, you can see here that this did not span from 0 to 1.0. This started from like minus 0.2, right? You see that this is actually because this is 0.0 minus 0.2. So when you give, explicitly state it, it will know that, oh, I'm to start my plotting from 0.0 to 1.0 on the x-axis and 0.0 to 1.0 on the y-axis. That's why you discover that if I run this again, you see that it has changed back to 0 to 1.0 and 0 to 1. So most times you want to declare that, you want to actually show us how your plot should look like. So you need to tell Python, oh, I want my plot to look like this. So for the x-axis, you want to tell us what type of label you want to use for your x-axis. So that's why we gave this x. You can always have something else there. You might want to give it, students. So if you give it students on the x-axis, to change it to students. So it's just that way. For y-axis too, you want to tell us, oh, the label on the y-axis should be y or anything you want it to be. Then you want to give us the title of the plot. You remember that when you were doing your exams those times, you get negative marks for not specifying the title. So here too, we expect that you give us title of your plot, because because without the title of the plot, we won't actually know what the plot is there for. But with the title, we can infer, oh, this is what this is and other things. So PLTs does show just tells you that, oh, after I have specified all this, then just show my plot. So that's what this does. Show my plot. I've given you all the configurations. Show my plot. So with that, it gets plotted. I believe this is clear, right? Is it clear? I want a single yes or a yes from someone. All right. Any yes? Okay, cool. Yeah. So that's it. So exactly, yeah. Thanks, Emmanuel. Thanks, Gloria. Yeah. So now we'll go on to another type of plot, in Python. But never forget that your data, you need to also consider your data when you are creating plots. But here we just want to be generic, all right? But in reality, you need to know what type of data fits your plot. Or sorry, what type of plot fits your data? It should be the other way around, converse of it, all right? So let's go on to bubble plot. Since we've done scatter plots, this is easy. The bubble plot is another type of scatter plot, but the beauty of it is that we can give sizes to each of our points. Now, for example, for this kind of scatter plot, you see that we are giving it an area. It means that we are saying that for each of these points, imagine you want to show population density, or you want to show area of a particular point. So, or you want to show the size of a particular data point. So that's what we use this kind of plot for, in such a way that, and we call it bubble plot, in such a way that you can specify area when you are declaring it. That was what this area was here for. But this was actually hypothetically generated. But in reality, you can do it. Maybe you have a population density or things like that. So colors is also for, maybe you want to give different forms of colors, but it is not necessary. I think Python can auto-generate that for you. Then, so the axis, we specify the axis again. We want it to range from 0 to 1. We specify the labels as we know. Now we are introducing one more thing also. So this is progressive, all right? Now we want to introduce what we call a legend. I believe most of you must remember legends. Legends are actually what helps you to know what extra variables in your plots are for. So the legend tells us that, oh, when we see circles like this, they're actually bubbles, all right? So that's what that is there for. So if you run this, oh, bubbles, all right? Now, this legends actually comes from here, you know. So if you change this to maybe area, let's say, so this changed to area, all right? So if you want to change your legend, you can always change it from the label here. So I just wanted to point that out for you. Now the area, actually you can, if you have a data and you want to plot that data, but you also want to show sizes of different points. So you can have a separate column that gives you the size of each of those points. So that's the importance of the area, all right? So that helps with that. So I think we are done with scatter plots and bubble plots. Okay, so I don't actually understand French, Roman, but if you can translate to English, I think I would love that, right? Okay, don't let me try. So let's go to another type of plot. Here, imagine our scatter plots. We just did scatter plots here, but can we have maybe like a link between each of these points, or can we? Okay, okay, all right. Can we have links between these points and see maybe we can get a pattern in the points? So that's where we have what we call connected scatter plots, and it's very easy to do. What you just do is you you specify in your plot what you want to do. This dash means that you want to use lines to connect each of them, right? This dash you are seeing here is like you want to use lines to connect each of them. And the zero just specifies that you want to, each point you have, dots like this. So that's what this is for, you know. So you can see that, but now you discover something that there's actually no pattern in this. This looks like what we call Brownian motion for the scientists around us. It is irregular, it is just random. And this shows from what the kind of plot, the kind of data we generated. Remember that our data was actually a random data. And so we expected that this plot should also show randomness, all right? But if you have a data maybe you got from the field or something, you can create nice plots that would not show this randomness. If your plots are showing this kind of randomness, it means that that type of plot is not actually feasible or is not the best for your data. You have to do for another type of plot. And so we also go to other types of plots here too. So I also want to show you that here we can also change colors, all right? For example, if I specify a B inside this place, I can change the color to a blue, all right? If I specify R here, I can change the color to red. So that's another thing you need to note, And this, it can be written any way around. You can specify 0 first, R next, and dash second. It will still work, all right? You still have the same type of plot. All right. So yes, okay, exactly. So you can actually do a lot of things with connected scatter plots. Sincerely, it's just the sky is the limit. You just have to think it and see how you can do stuff. So you discover that. So let's go to what we call a line chart now. Line chart. All right. So we are done with scatter plots. We've talked about connected scatter plots. We've talked about bubble plots. All right. Don't forget those three types of plots, and it can be useful in your own exploration too. So now, what other types of plots do we have? I think we need to also consider that sometimes our data is not just in form of dot dot dot. So let's move on to what we call the line chart. All right, the line chart is actually meant to connect different points together. But you see that in this plot here, our line chart was also just random, all right? So it means that our data is not fit for this type of, or our plot is not fit for this type of data. So we might have to create maybe another data that will be fit for it, all right? Because you see that it's not fit, all right? So now to do that, what we try to do is we generate new data points. So that's what we did here. Generate new data points, 100 data points. All right, we are generating 100 data points that are between 0 and 10. So the maximum value will be 10, the minimum value will be 0, and we have 100 data points in between them. So that's what this linspace does. I think someone has explained linspace. So we tell Python that, oh, okay, we want to initialize our figure. Now we create our plot by using plt.plot. Don't forget the different kind of plots we've been using. Some places you see us use plots, some other places we use scatter. So don't forget those kind of things. So, but the universal one is plot. If you can remember plt.plot, you can do a lot of things with just plots without even remembering what scatter is or any other thing. All right. So we specify our X label, our Y label. We tell it that we want the legend to show because that's what this, without this, we will not have this legend. All right. And the legend takes our label, as I told you, and we show. Because this our data is actually um, is actually, don't let me call it uniform, but it's between 0 and 10, and it's and we are using it in both places. So it means that I will generate a straight line, and this graph is actually a graph of y is equals to x, because here you can see that our data and our data are the same. So we are using x to be data, y to be data. So this is like saying x equals data, y equals data. So a graph of y equals to x is actually a straight line, and it's discovered that our plot here now works perfectly because now it's just a straight line. So okay, I think there's no. Let me see what plot takes as input here. Mm, okay, it's just arguments. Okay, so I don't need to specify x or y. Okay, now that we've discovered a lot of plots, I hope we can go further. Now imagine we've only been plotting one plot, but sometimes you want to have 5 plots together, 7 plots together, 10 plots together, like, so that's the next point we're going to now, what we call subplots. Now, with our background, I believe we can talk about subplots, all right? So now in subplots, what we want to do is we want to generate this kind of data in such a way that we have 4 different data on the same plot. You can see 1, 2, 3, 4. They were plotted together, on the same plot. So that's what we want to go into now. We are going deeper, all right? So I want us to focus more because this is getting more interesting. So now to create subplots, you just tell your Matplotlib that you want to create a subplot. And how many rows of subplots do you want to create? You want to create 2. How many columns of subplots you want to create? 2. So that's what this means. You can see 2 rows here. Row 1, row 2, column 1, and column 2. So that's what that is specifying there, all right? That's 2 rows, 2 columns. Figure size is, we are saying 15 by 15. You are trying to say, okay, in pixels, what should be the size of your plot? You can do away without the figure size, but the more you specify for your plots, the more accurate your plots will look. So that's why this is here. So now, after you have specified to Matplotlib that, okay, I want to create subplots, it actually gives you 2 different things you can manipulate to actually get your plot. So that's why you see that we are getting back a figure and we are getting back our axis. This axis is to actually manipulate each of these axes. We take this to be an axis, and this one, this, and this to be another axis. So that's why Matplotlib gives you this. So with this, you can then manipulate the plots, all right? So here now we are saying that, okay, on the first row and the first column, we want to plot a scatter plot using our x and y grid. We know we've declared x and y before. All right, so that's what this is for. So, and we are saying that, okay, this is just to say that, okay, we want the title of our plot to be this, all right? And so you can see the title is here. On our first row, and the second column. Remember that Python is zero index. That's why you see me saying first row, even though I'm seeing zero here, but I'll still say the first row, all right? First row and second column. We want to plot, we want to create a plot, which is a line chart, all right? And so X, Y. And so you see that we're also giving it a title. Don't forget that when you are creating subplots, the way you specify title is different from the way you specify title when you are not creating subplots. If you look at here, we just said PLT, the title, all right? But here, when we are creating subplots, you have to say set title. So that's a difference you need to note, all right? So when we say that, so this generates the second plot here. So we are saying first row, second column. So it generates this for us. The same thing with first row. No, this is second row, first column. So second row, first column, we specify that we want to generate this kind of plot. And second row, second column, we specify that we want to generate this kind of plot. And that's what we have here. All right, so you can see that in one single go, we are plotting 4 different things on the same plot, all right? And we call them subplots because each of these are subplots. So if you run this, we have our subplot. You guys can see that it's interesting. So far, hope you guys have gotten something. I want a yes if you've been enjoying the plot so far. You know, I want a yes, yeah. Can someone give me a yes if you've been enjoying the plot? Okay, good, 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 good. So plots, exactly. So they are dynamic, and you have to be able to specify what you really want when you are creating plots. So after now, you can open up this notebook and generate different kinds of plots and play with it and specify different things. You know, it helps to solidify the concept more. So even though we have created plots, but what we want to do is we want to make it more beautiful. We want to specify some things. For example, we don't even have labels on the x-axis and y-axis. Now we are seeing different things. The same ranges here are also showing here. You know, so we can actually try to remove some of these things and make it more interesting for us to use. So that's why we need to run this. All right. Now we can generate some. This axis dot flat is actually like an iterator, and you're saying that for each of the axes, you want to create labels for it. So you want to create x label and y label, and the x label should be called x dash label, and the y label should be called y dash label. You see what will happen when we run that. Right now, you see that we've given, you know, x label and y label to our plot. Now we know what is there, what is there, what is there, and what is there. All right. So, but we still have these things here, these ticks. Since this plot, this plot, this plot, and this plot, since they are similar, why can't we just remove this, remove some of these ticks? We don't really need them. So that's why we can use this next one to actually hide the ticks. And what is specified that just label the outer. So we only have our coordinates here. Can you see? We only have the coordinates here. The coordinates have been taken away from here. So that when we want to look at anything here, we can easily look at the left. Since these coordinates and these coordinates are similar, so if I'm looking for something here, I can always trace it back to this place. I don't have to have it here any longer. And the same thing for this place. If I'm looking for something here, I can always trace it to the bottom, since the 4 plots are together. All right, so that's what the subplots are for. So don't forget, when you want to create subplots, you initialize it with subplots. It returns 2 things, the figure and the axis. It is this axis axx that you manipulate. You see me manipulating them and specifying for each of the rows and each of the columns the kind of plots I want to make. So that's the basic things you need to remember about subplots, all right? Subplots. You can always come back and check codes. Now, I also want to mention that when you are programming, don't be afraid to go back or return back to your codes or what you've written before. Because most times, even us, we don't have everything in our brain, all right? You can always refer back to references, refer back to things you've written down earlier. You are not a dummy if you do that. none of us also remember everything we're also typing, all right? So it's important to remember that. So let's go to histograms now. Histogram is very easy, all right? As I said, you tell Python, okay, I want to create another plot that is different from the ones I've created, and you just use plt.hist, and you give it the data point. And now, what the binning here is for is that now when you have data points, you know, you want to bin them and count them. So that's the way histograms work. And after now, if you don't really understand how histogram works, you can maybe go online and check histograms. You discover that most times you want to bin contiguous data points. You know, maybe 30 bins, 20 bins, and things like. So that's what we are trying to do here, such a way that we give it our data and we create bins for it. So that's the way histogram works. You see that some of these bins don't actually have any values, and it's because we are using random generation. So even in real life, sometimes some of your bins might not have data. It's possible too. So that's what this is for. All right. Now this is getting more complex. All right. But this is for the scientists among us that actually want to see how to visualize probability distributions. All right, so we'll be doing some of that here. So all right, so now remember that we generated a Gaussian distribution earlier. That's our y is actually our y is actually Gaussian distributed, or normal. It's a normal distribution. So we want to visualize. Okay, let's even prove to ourselves that it's actually a normal distribution. So, and we want to create subplots. You discover that. So I specified subplots here, and I'm saying how many rows of subplots do I need? One row and two columns. So that's what this means. And figure size, I want to say 15 by 6. I don't need 15 by 15 again because it is just a one row. All right, it's just one row, so it might not be necessary to do 15 by 15. That would be too large on the column side. So for that, I specify for the first part that, oh, I want to generate an histogram. All right, so that's what you are seeing here. I specify histogram density. Yeah, you're just trying to show that sometimes you have a lot of parameters in these things that sometimes you just need to play with them to really know what each of them entails. But let's go on. Now, the bin function before doing some plots for the regression. Okay, someone is already answering. Okay, so the bins, I'm specifying the bins that, okay, I want to generate 30 bins, and I also want to give it a Y label. So that's why you're seeing here that this label can also be used when we need to perform legends. You remember the other time that we were using our labels for legends. So this is just to set the title, as you know. Now the legend, you can see that I'm creating legend here now, but we're adding something else to the legend. What did we add? We are saying that the legend should appear on where? On the upper left. That's what this location is here for. It's saying location upper left. That's why you see that the legend is appearing here. Formally, if you look at our legends, they were appearing in different parts. You know, they might have appeared in different parts. You can see this one appeared on the upper right, this one appeared on the upper left. But here, you want to explicitly tell your plot that it must appear on the upper left, and that's why you are specifying here that upper left. All right. Now you can also add text to your plot. I know some of you might have been asking that, how do I add text to my plot? So that's what this is showing, that you can add text to your plot, and you can specify the coordinates of the text. You want where should your text be located? So you see that it's located at 0.8, 2.5 on the 0.8 on the x-axis and 2.5 on the y-axis. So you look at it. So it's saying that, oh, my text should be there. So that's what it's saying. And what should I put there? I should put the mean and the standard deviation. So that's what this means. Now you might wonder, why are we using dollars and stuff like this? This is actually like in a LaTeX format. If some of you are conversant with LaTeX, you understand that when you want to write things in LaTeX, it's easy for you to write equations or things inside in this format. So this is just a LaTeX format of showing what we have here. You know, when it displays, it will not show the dollars any longer, right? Now, so the x limit is just to show the mn and mx is actually being used inside here to generate your plots. All right, so don't worry about that for now. All right, this KD is actually coming from here because we want to create this kind of PDF. So we need the KD, and that's why we imported SciPy the stats. It's a statistics library. Um, just as scientists might follow this part, others, if you think you not really be doing a lot of distributions and stuff like that, you might just ignore it. All right. So now our first plot is similar to the second plot, but you discover that we are also plotting a distribution over it. So that's why we need to specify in the second plot our KDX XS and the probability density function of our plot. So that's what this is showing us, that okay, we want to create a probability density function over it. So that's why you see this density function here. All right. So where should be the location of my plot? Upper left. I can change this to upper right, and you see that when I generate my plot, it will be on the upper right there. So, all right. So you can see it here, upper right. But just to show you that you can specify bottom, you can specify, it depends on, there are a lot of things to specify when you are making plots, you know. And so you can see the density function over it. This looks like a multimodal density function. Maybe it's because we don't have a lot of values, but you know, if you look at, don't let me go deep, don't let me go deep into distribution so that I will not confuse others. Right? So that's just how to generate plots and this kind of double plot. And now also note that you can see that we created two plots on top of one another, right? This is a plot, this is another type of plot on top of one another. So it's possible to create different plots on the same subplot. The first one was created using histogram. The second one was created using plots. All right. So you can keep creating on an axis. You can create 5 different types of plots, because I know sometimes you might want to show on a single plot different things happening. So you can use a single axis to do that. It's possible. All right. So now now I know you've been working with arrays and things like that. So I want to show you how you can actually use a dictionary to generate plots. All right. And for that, we'll be creating bar plots. So imagine I give you different languages and I tell you the total number of students that are actually, oh, beans, okay. So beans are for, I don't, let me see if I can annotate something here. Okay. When you have your data distribution, most times, let me show you this. Now you have different values like this, you know, like different values on. I'm taking this to be maybe your x-axis, and maybe this ranges from 0 to, let's say, 100. Let me write it here, 100. All right, 100. Now you have different data points, like everywhere, like you have them differently. So now the thing is, the beauty of charts is that you can look at this kind of different data points and say, oh, this this these are similar, these are similar, these are similar, right? They are similar. So why not just create bins for them and show them together and count the total number of data points that are in that bin? So that's what we are doing here. So when we bin, it's just like you are saying, okay, this is similar data points. How many of them are there? We say 1, 2, 3, 4, and we plot all of them as one. So that's why I see that some places don't have bins, is because maybe we were in this region that there was no data point at all. Yes, you can read our code in Python, but even you might not necessarily even want to do that. Jupyter Lab and Jupyter Notebook can actually, you can just make use of R directly in Jupyter Lab or in Jupyter Notebook instead of converting, you know. But you can do that. I know there are some other libraries that can help you with that. So that's what bins are for. Okay. So I hope I've enough help there. So let's go on to, okay. Okay, good. So I think we are clear with that. Okay. So now for our bar plots, now we're talking about histograms, but sometimes you want to create bar plots in such a way that you want to show the number of students that are maybe programming different types of programming language. So these are programming languages. Some of them you might have heard of, some of them you might not have heard of. All right. So imagine I give you a dictionary like this, and I tell you, oh, the total, oh, I've counted my statistics and I say that total number of people that are programming in R are 40, total number of people programming Scala 37, programming Spark is 35, like that. You understand? So what kind of plots can I create with a dictionary? So what I can do is I can retrieve the languages using dot keys. You remember from yesterday, if I retrieve dot keys, it gives me all these keys as a list, right? Then if I retrieve the values, it gives me all these values as another list. So I can then plot this as a bar plot. So that's what this is doing here, all right? You can print this and print this. You discover that it's just a list of each of these. So, and simply. So now imagine I give you this data and I give you this plot. Which of these will you prefer? Can someone just answer me? Which of them will you prefer? Imagine I give you just this data, or I give you this plot. Which of them do you think is more intuitive to interpret? Good. You discover that the plot is easy to interpret because here easily you can see that, oh, Python and Cython are close. Now you might not really understand what I'm trying to say now, but if your data is very, very large, it's difficult to actually see what we are showing here. All right, but we plot, good. We plot, you can quickly see what is happening and know that, oh, this is the minimum. That the minimum set of people, students, that they want programming Spark. So it can show you that maybe Spark is not a good programming language. Actually, remember that this is just hypothetical data. We are not saying this is real. But if you have to interpret this type of plot, if I show you that which programming language do students program the most, it's easy for you to show from this plot that, oh, it is Cython. All right. Which programming language do they program the least? You can tell me, oh, it is Spark. Things like that are easy to interpret from plots. So that's why plots are very, very good. Now, there are also a lot of things you can do with plots, but I don't want to go deep down into the remaining aspects of the plot. And the reason is I want you to explore them yourself because plots are things that you can always manipulate to do many things. So, for example, you can see that you can stack different plots together. I'm not going to explain this. I'm just giving you an idea that in case you want to stack different plots together, you can stack plots together. For example, you can also try to do this kind of stacked bar plots in such a way that you have two different plots on top of one another, showing the same thing. Right? So you can do that too with your plots. Even pie charts, you can see that it's interesting, right? That you can do pie chart, you can actually plot pie charts with your plots. And it's very easy. You just see that you specify .py, and that's all. All right? .py is just what gives you pie charts. The remaining are similar .bar, as we know. But what now differs is what you specify inside your plot. And this comes with practice. Knowing what to specify inside the plot comes with practice. The more you practice, the more you visualize different plots, the more you know how to actually manipulate your plots because, it can be helpful. Now, so you can have pie charts. Now, another one you can have is the box plots. Yes, you can always save your distance. You can even right-click and save. You understand? You can right-click and save on your document. So it's very easy. All right. You can just right-click, save image as, and you save your image. You don't have to do a screenshot. You can just save your image as, and you can save it anywhere you want to look for it. Maybe in pictures, or let me save it in pictures. Download it. Okay, so that's it. You can always save your images, all right, after doing plot. So that's why these interfaces are good. You can quickly experiment, save your data, save your images and do a lot of things. So So for box plots, I will not go deep because it's an advanced type of plot. But those that actually will make use of it will find it interesting, and that's why it has been added here, all right? Because box plots help you to know what we call different ranges of the data. You can know your median, your interquarter range. You can know your Q1, Q3. That's your first quarter, your third quarter. You know, you can do a lot of things. You can even determine outliers from your data. I don't want to go deep. But if you really want to know more about interquarter range, you can go online and study about it. So if you want to know more about box plot, you can go online and study about it. All right. So I'm just showing you that you can do all these things with Python. You can pie charts, box plots, lines, scatter plots, a lot of things. So everything is possible in Python. All right. Now, so that I will not overwhelm you, we'll just quickly go to exercise. Maybe we'll have like a 1 minute break. We'll go to the exercise and try to see what we can do in the exercise. All right. So thank you very much. Yeah. 1 minute break. Yeah.
Thank you very much, Savade. But I guess the exercise, couldn't it be something they could probably do later on their own and share, since it's like they have to create the data set and try to visualize it. So are they?
Yes. So it's something also they can do on their own.
Yeah, because it's already
Exactly.
time. It's even actually past time. So maybe
Exactly.
they could
Exactly.
actually do it on their own or
Exactly.
something.
Plotting is interesting. They can just take this notebook, generate different data, manipulate it, visualize it, you know. That's how you get used to it. You'll be happy when you see your plots, how beautiful they can be by manipulating Python, And that makes Python very interesting to do. To use. Yeah, thanks for the answers on the group too. I'm seeing different types of answers for saving plots. Yeah, exactly. You can save your figures in different ways, you know. But because you are online, that was why I had to specify that method, because now you are not on your local directory, so you might want to save stuff on your local directory. So the easiest way is just to right click and save. All right, but other methods they've specified is very, very good and very accurate. All right. Yeah.
Okay, so Sewade, I think the suggestion would be to end here so that
Yeah.
they could try
Exactly.
this on their own, but we would
Exactly.
put a sample solution. We'll just create a toy data set and then do some visualizations with that.
Yeah.
Then you can follow suit and using your own data sets. But as I mentioned, if you have any problem, concern, you could reach out to any of the TAs. So the TAs have been CC'd in your emails. So normally, if you just look at the emails, you'll be able to tell whose email. I think normally our names are in there. Or if you reach out to one person, you can get to the other person who you want to speak to. So I guess that this would bring us to the end of our 2 days Python tutorial. I understand that this has been quite a race, more like, because I mean most of us are beginners, right? So some of the things wouldn't have made sense, but that is completely fine, and you shouldn't worry about it. You just have to take your time and go through the materials on your own step by step, and everything will begin to make sense. So on behalf of the TS, on behalf of the Women Promoting Science to the Younger Generation members, we want to say a very big thank you to all of you for taking time and efforts to be part of this our workshop. And we'll be very happy if you could complete the feedback forms that I'll be sending right after, so that it could help inform us for our subsequent or future events. So maybe I would just want to take some 5 minutes. The tutors, maybe if anyone has like 30 seconds, you want to share a tip with the participants, something they can go along with, I think this will be the right time to do that. You can just unmute yourself and then speak, just 30 seconds. You can mention your name again and then just say something to them if you have anything. I don't know, Yolande, do you want to say anything? Bernard, say what you.
Yeah, I want to say something.
Okay.
Hello, guys. So I really hope that the 2 days programming has really been a plus for you all. And I can only say that it's a struggle learning how to program, how to get into this analytics world.